Hello, my name is Matthew McKnight. I am the programming mentor for the MinuteBots, Team 4536 for the FRC, and the Millisecond Bots, Team 16806 for the FTC. And we're going to talk about the OpMode in FTC, one of the four horsemen. We're actually just going to create an autonomous mode as the sample, but I'm going to go into a little bit of what OpModes are as well. So let's get started. Congratulations. Look at all the classes that you've made to make this robot work. The commands, the systems, the robot, even a teleop mode. We're going to look at now at autonomous modes. Autonomous modes run without any driver interaction at all. Take a quick look at the difference between an op mode and a linear op mode and why we're going to use a linear mode in this particular autonomous mode. So let's talk about op mode. Op mode is kind of the map maker of the four horsemen. It is the one that determines the path by which the robot is going to go. It controls what the robot is going to do. And to do this, there are certain things that it has. For example, because it is an op mode, when it is instantiated, it has a hardware map object called hardware map. And the hardware map object is a collection of all the hardware that is actually on the robot, so that you can extract it out of hardware map and use it to create the subsystems, which you then can use to create the commands, which OpMode will use. Now there's two main types of OpMode. OpMode and linear OpMode, which actually inherits from OpMode. But they're very different in how they interact with the process of what the robot's going to do. And one of them, OpMode, is generally better for teleop, and the other, linear OpMode, is better, you guessed it, for autonomous. So the op mode itself, the default class, has three main methods. There's five total, but three main ones: init, loop, and stop. Init does the initialization of the op mode. It is the one that gets everything set up for things to run. The loop is what it describes. It loops through this method over and over and over again every so many milliseconds. And whatever is within the loop method will get called every time it loops through. And then you can hit stop and it will stop the process. This is good for teleop because for the most part, you want it just to keep looping and checking things. You want to keep checking what the drive is going to be. There's no set sequence of events. It's just sort of catch as catch can. On the other hand, in linear op mode, there's really only one method, and that is run op mode. There isn't init, loop, and stop. You call run op mode, it runs through it, and it's done. So if you want it to loop, you actually have to create loops and put them into run op mode. Now, because it starts and runs through, there's another method in linear op mode that's very important called wait for start. And what that does is you put it after you've done all your initialization code, and you put wait for start, and it waits until you push the start button. Otherwise, it would just run through it before you would even hit the start button. This is really good for autonomous because it is a sequential order of events, which is exactly what you want autonomous to be. You want it to go forward, you want it to pivot, you want it to pick things up, all of it in a sequence. So those are the two, quick overview of the two types of op mode. So right click, choose new Java class, and we're just going to call this one sample auto mode. Now, because it is going to be an op mode, in this case a linear op mode, it needs to extend linear op mode. Remember, extending is basically like cloning. There's only one method. If you right click, Alt Enter, you'll see implement methods, run op. Run op basically is the one method of linear op mode as we talked about. Because this is going to be an op mode, we have to add some annotations. Remember the @ symbol? And we're going to say it's autonomous. That's the annotation we're going to add. And in the parens, we're going to put name equal sample auto mode. And the group is going to be autonomous. So once we've done that, we basically set this up for what we want to do. And we're going to go to run op mode. And the first part is going to be what is similar to the init method. So we're going to use all those classes you have already created. First, we're going to need to create a robot. The robot is the one, if you remember, who instantiates the subsystems and the commands and then makes the commands available to OpModes. So we're going to create a robot call it robot, equals new robot, and it needs a hardware map, which we have because we are an OpMode. It's part of what you get when we extend linear OpMode. We pass that into robot, and then the robot will give us the commands back. So the drive command is going to simply be robot.get drive command. Now remember, with the separation of concerns, the robot handles all of the creation of the commands. The OpModes don't care about that. They just want to get them from the robot. So the output command is going to be the same thing, robot.get output command. And the intake command is going to be exactly the same. And that means that in these 4 short lines, we have created what we need to do our autonomous method. Now, in order to get it to go for the start, we actually have to tell it to wait for the start. Otherwise, it'll rush ahead before we hit start. So it's going to wait till we hit the start button, and then we're going to tell it to do a sequence of commands. We're going to tell it what we want it to do at a fairly high level and let the command systems take care of that. So the drive command, go straight 10 inches. And then drive command, we're going to spin 90 degrees. Now remember, because this is a circle, this will turn us to the left. Once we're facing 90 degrees, we're going to use our output command to move the bucket to the position of 5,000, which is pretty high. And then we're going to use the output command to dump the bucket. Now, the key here is we actually have to pause here to let the bucket dump. So we're going to call sleep for 1,000 milliseconds, that's basically 1 second, to let the bucket itself finally dump the stuff. If we don't do this, it's just going to move on to the next command while the bucket is dumping. So once it's done dumping after a second or so, then we're going to tell the drive command that we want to spin negative 180 degrees. Basically, we're spinning around to face the other direction, going right, and then we're going to tell the drive command we want to go straight for, let's say, 20 inches. That's it. We have created an autonomous command just like that. And you can see it's a fairly simple command because of the whole separation of concerns. You can look at it and know exactly what your robot should be doing. So congratulations, all that hard work in creating all the other classes makes the creation of autonomous mode really, really easy. Have fun, and we'll see you soon.